Hello everyone, welcome at our core protocol sync this week. We'll share updates what was happening on the consensus, DSN and related things from last week, and what are our immediate plans. Shamil, do you want to start first as usual?
Sure. Let me share my screen. So last week I finished working on the pieces exchange between farmers and nodes. There are two merged PRs. One was for exchanging pieces from farmer and receiving it on the farmer's end. They mostly related to the object on pieces cache, L2 cache on farmer. Also, we merged the PR that gets pieces from cold storage, from archival storage from the farmers. In this layer, we get pieces from already plotted sectors and return it to the requester. This is why it's a little bit slowly than that those pieces that we can get from cache. And there is a pending PR for adjusting caches for nodes and farmers. During this PR, I also adjusted multiple constants, added different improvements for network behavior, like populating pieces not only put operations, also on get operations. I learned this from our community call with VP2P guys. And we have also a pending PR with Nazar. Nazar created the handler that returns actual piece from sector on the farmer side. So having these two PRs, we most likely finish the most important code for the first stage of the DSN V2. And next plan is to test it first on some several hours and several days. I spoke with, I had a call with Nazar, and he promised me a machine for this test. So the next goal is to start testing. I believe we could manage merging those PRs into early this week, and the rest of the week we will start testing it. Also, I implemented this code, I mean layer 1 and layer 2 for the DSN using KVM push model. I just remind you that it is less efficient than pull model, and the reason for that there is a currently there is a bug in KVM there, and I contacted the P2P team, Rust team on the community call, and Thomas, one of their developers, scheduled the bug for this week. So I hope he will succeed in this issue, because otherwise we need to fix ourselves, and it will take a little bit more time. So this is it. Finish, merge the PRs for the beginning of the week and start testing on the end of the week. This is my plan. Thank you.
Thanks, Shamil. For the stage 1 of DSN V2 for the testing, this will allow us to have a farmer to sync its plot from another farmer, and then
Yes.
and then join consensus.
Not from the farmer, but from farmer and nodes, just from the DSN.
Okay, got it. And would we be able to, instead of having a separate machine or testnet for that, would it be possible, I guess question for you too, Nazar, would it be possible for us just to do that on XNet 2? Just upgrade XNet 2 with the latest?
In theory, yes. But I will probably tune the settings, and I will restart it very often at least in the beginning. So I would recommend having a separate test for at least for initial adjustments.
I mean, we can start whatever we have, and if you need to change settings, you can just start a separate network in that case. But if you don't, then we can run at least something.
No, we can do that, but I don't want to mess with WeChank experiment, for example.
Well, I just want to get out of the habit of testing like different features independently, and just testing farmers and nodes, and just testing executors and nodes, and not testing the whole system together, because there's always like unexpected side effects the more parts you put into it. So it feels like it would be better just to test the entire end-to-end system if possible.
Let me be confident that it works for at least for a couple of days, and then I will gladly merge with XNet 2.
Okay, sounds like a deal.
All right. Any other questions to Shamil? Cool.
I just wanted to add that we will have another iteration of PC cache modification after the bug fix. I just assume that we know that.
Yeah, we'll replace push model with pull model.
Yes, exactly.
Okay. Wucheng, what do you have to share?
Actually, no major updates on the core protocols last week. There are only two minor PRs related to payload domains, which I believe we already have covered them. One is to verify the state routes. The other is to remove the perimeter receipt existence check from the transaction pool. Other than no other changes on the core protocol.
Okay. Ivan, do you have any issues, blockers, or requirements from Node or Farmer with what you're doing on the ZK side?
For now, no, I believe. Yeah. For now, I'm just reviewing like your code and working with SDK for now. Yeah, right now I'm just working on the initial support from the node. So yeah, no focus for now.
Is it based on Gemini 2A or the latest?
Like the latest, but not the most latest, but the
Okay.
code which you are pushing. Yeah.
Okay.
Yeah, working on the update. Yeah.
All right. Thank you. Let me share my screen. This is the pull request that Shamil mentioned. Okay, I think you should see it. Basically, the idea is to integrate whatever farmer is writing to the plot with the DSN so we can actually make use of it. You can read the description if you want. I'll just walk through some major changes. So first of all, the challenge was that we didn't really have any way to know when something is happening to the plot. So I have added the event handler. Basically, like in Node.js, if you are familiar, you have like on something, and you can specify a callback function that will be called every time we plot new segment, new sector in this case, and there will be some information about that sector, like what the index is, what the ID is, what are the pieces that are within it, stuff like that. So we can intercept it later and do some things, let's say publish to DSN if that happens. So that was the first commit in here. It doesn't really doesn't make use of that new feature, but just exposes that. Then there was small simplification, doesn't matter. Then there is another problem that in the previous start of the farmer, there could have been something already plotted, and you need to be able to access that and like republish it or whatever. So I have exposed a few other methods on the DSN side. On the single disk plot side. So first of all, you can query how many sectors there were plotted so far in the plot. You can also get all of those sectors as an iterator. These are the same plotted sectors. So you can just go through them one by one if you want. And alternatively, you can get a piece reader, which is another new feature, where a piece reader can be used later to tell, I want the this particular piece to retrieve from the plot, and it will actually do it for you. And this piece plotter is actually an abstraction. So there is a separate file that implements that feature, and it has just one public method here to read the piece. The API is not actually a piece index. That's not what this plot is dealing with. It primarily deals with sector indexes and piece offsets within those sectors. And the whole plot is just a sequence of sectors. So that's the API that the DSN has to transform requests into, or like rather farmer will have to transform DSN request into those parameters before they can actually read something from the plot. And again, this just introduces new APIs. It doesn't actually make use of them. After that, I have modified the plot a little bit. So the observation is we have this like dependency, like chicken egg dependency between the DSN and the farmer. When DSN starts, it needs to have a handler for, you need to provide a handler that will be responsible for returning pieces. And at the same time, the plot itself requires a networking to work. So they depend on each other, essentially. And also, we have one method that allows us to return all of the pieces that we have plotted so far. We have a method to subscribe to the interception of those, but we actually need to do them in such a way that we do not miss any pieces. So in order for that all of that to work properly, I have introduced a way to actually block all of the internal functionality of the single disk plot until it is basically polled, until you call this run method, which is asynchronous. So until you call that, nothing is actually happening, but you can still use, you can get the piece getter, or you can read and iterate all the pieces plotted or sectors plotted and stuff like that. So basically in all of the background threads that we have, we just wait for the start notification. And then in the run, we are sending the start notification at the very beginning. That will be useful a little bit later. And then with all of those primitives created, we can actually wire those things together. So in the farm command, we are creating a DSN, but also we provide additional parameter to DSN with the mutex that contains readers and pieces. Pieces is actually a mapping, and readers are readers that allow you to retrieve those. And then we, I can just show comments for now. And then we can read all of the sectors. We can get all of the readers from all of the plots, and then we can actually get all of the pieces that were plotted from all of the sectors and all of the plots, because there can be multiple on different disks. And we have essentially all of those two components that we need for DSN to work. So once we have those, we can actually take that mutex and we can replace the internals with the proper values. Before that, it is just none. So initially, when you start the farmer networking, it will not be able to respond to those requests. But a few moments later, once all of this is initialized, it will actually be able to. And because we are not doing anything internally within the single disk plot, it is fine to iterate first and only later to subscribe to the new notifications, because nothing will be actually plotted in between of those two events. We made sure of that. And yeah, once we are ready to actually run all of those plots, we are first subscribing to new plots, and every time something is to new sectors, and every time something is plotted, we take the same exact mutex we had here, and we just extend a set of pieces that we are aware of into that hash map. In that particular case, the key is the piece index hash, and the information we store within that mapping is the plot offset, which we need to use piece reader. We have a sector index, again, because we need to use that in piece reader. And we also have a piece offset. Plot offset is an index of a plot, because we have multiple on different disks. So using this plot offset, we can retrieve the corresponding reader, which we have a vector of. So all of those together basically allow us to do what we need. And in the DSN initialization, we had this empty callback to respond to the piece by hash requests. Now what we can do, we can actually go into the mapping, we can extract it and lock it. From the guard, we can get a list of readers and pieces. We can check if there is a piece that we are looking for. If there is, we can get the details that we've got from the map, and we can read it from the reader, and then we can return the piece itself from the disks. And that basically completes the whole workflow. We have a few new primitives. Potentially, you can combine these things differently. That's why we don't expose the farm command as such from the library API. We just expose single disk plot. We expose the networking part, and you can wire them together the way you want. For instance, in the future, what we'll do, instead of requesting these pieces from the network, we will first request it from other plots that we have in case there is an overlap. And also we can do some optimizations of similar nature in other places. But this is for the initial implementation, the way it will work. There are still some issues to resolve. There are some nice suggestions and comments. I hope to get it done later today. And with that, you should be able to test the whole workflow together. Thanks to Shamil, he provided me exact commands I can run to test this thing together. So I don't have to guess. Any questions about how this works or anything? Hope it makes sense. Okay, I guess that's the update on my side then. This week I'll be working on upgrades to the consensus from the initial simple version that we have right now to a different version based on ratio coding and KZG, if the spec is ready. Otherwise, I still have one bug to figure out with a report from EA1 and details from there. And also there are some code reviews to do. So should keep me occupied for a little bit, but hopefully we'll get to the consensus upgrades very soon. Okay, Daria, what about you?
So last week I was for some time helping with the Jeremiah's new guide to KZG for Subspace, basically reviewing the existing constructions and also adding some overview of the mass that we're going to be using, specifically some optimizations and things, which got merged with his document he shared before. And then the last 2 days of last week, I was working on trying to prove with the library forked from the semi with PR paper. So they got code there. So I forked that code and I tried to prove whether with systematic erasure coding that we want to use, the commitments will still work for the property that erasure coding of commitments should give you the commitment to erasure coded data. And well, that succeeded, but it's using a very straightforward approach that we'll have to rework when we want actually to get to this in our consensus v2. Because it's one of the reasons is that it's not working with the library like interpolate function that would interpolate our data. So I had to, because I had to write a separate function to interpolate our commitments to make it work, I used the same function to interpolate our data, and it's much, much slower. And I have spent several hours trying to make them work together, but then I had to abandon it. So when we get to this, well, actually in Subspace, we'll have to revisit it again. So that's the thing. And some of the things are slower because the compiler didn't let me do what I wanted. So I basically have to multiply every single coefficient by some other coefficient. But to make it faster, I could move it outside of the sum, and the compiler didn't let me. So we'll have to revisit.
But those are just optimizations, right? The result will not change.
It shouldn't. Well, we have to we have to see, but it shouldn't. And yeah, so it works as a proof of concept, but when we get to this in actual implementation, we'll have to revisit it. And then
Actually,
today, yeah.
On that note, I don't think we need to, Daria. I think we can actually use that for the first stage of the implementation, since it's only over the commitments, since it's, even though it's inefficient, it's a very small amount of data that we actually have to encode. And it's more important to test the end-to-end workflow than really to optimize it right now. Well, it's not like we're erasure coding the whole data in this using this method.
Well, we actually are now, because it doesn't work with the interpolate in the library. It kind of, so basically because the way I interpolate our commitments, I iterate over like roots of unity every power, so like every index. So my register-coded data is in the first half and then extend is in the second half. But when you use interpolate from the library, they kind of iterate like over squares, I think, of roots of unity. So the data gets in the columns. And I have spent several hours trying to make these things align. And so I used to have only the first columns verify the next not, or every even column verify and the every odd column was false. So I kind of abandoned it. It's one thing. And another thing is that he is using different library than we are using. So the syntax is also slightly different. So we'll have to look at it again anyway.
I think what Jeremiah
Okay,
meant
let's-
is we are not replacing archiving yet with that new approach.
Yeah,
So that's like an isolated
maybe.
piece of logic.
Yeah, let's push this discussion to the research
Mhm.
sync.
Okay.
It's good context, but it's probably not worth going into this much detail with everybody right now. Yeah, and by the way, I just to reiterate what Daria said before, it's like it's a big deal. It's like a really big deal that we proved that this works. This is like a new construct, really. We took two very recent papers and put them together and proved that they work. So there could even be like a paper that comes out of this. And it's pretty essential for an efficient version of our V2 consensus. So great work, Daria. Thanks for really digging into this to figure out how to hack it together.
Well, I'm happy it worked.
Okay, that's awesome. I think, Ning, you probably don't have any updates today just yet. Jeremy, what about you? Do you have anything?
Nothing specific to protocol.
Okay. Anything else we need to discuss?
Yeah, I just wanted to comment on what you'd said earlier, Nazar, about the next stage for V2. So we'll be talking about that at the R&D sync after this, and then that is my next, during our one-on-one, we can start talking about the next stage of implementation. So it's pretty clear what we need to do, at least in my head right now. I just need to get it on paper.
Okay. So I guess the next update might be a little bit longer and more eventful on the consensus side. I mean, on the implementation. All right. Great. Thanks everyone for awesome work last week. And thanks for everyone watching this on YouTube. Hope it makes sense to you. If not, you can actually leave comments, I guess, and you can address some of these things next time. Yeah, see you next week.